Go buy yourself a good pair of rain boots and start stocking up on food, because a Godzilla El Niño might be on the way. If it really happens, parts of the southern United States and southern Europe could soon be hit by intense rainfall and face a much higher risk of flooding. The same goes for South America. A series of catastrophic rainstorms could flood roads and trigger huge mudslides in countries like Peru and Ecuador. While some places deal with too much rain, others may get none at all. Indonesia and Australia, for example, might experience severe drought, which could cause massive wildfires and wipe out their water supplies. Experts think El Niño could happen sometime between June and August of 2026 and stick around until the end of the year. There's even a 1 in 3 chance it could turn into a super El Niño by late fall. I mean a really intense, catastrophic version of this event that's also known as the Godzilla El Niño. The problem is, even if you're in part of the world that isn't directly affected by this phenomenon, you might see its consequences anyway. Because it can ruin crops and cause global food shortages. That makes your everyday groceries like rice, coffee, and sugar way more expensive. No one wants that, but it's not like we can avoid El Niño. It's just a natural part of Earth's climate that's been happening for millions of years. It all starts in the Pacific Ocean. And since this ocean is so huge, whatever happens there kind of ripples across the whole planet. You see, under normal climate conditions, tropical winds blow west along the equator, pushing warm surface water from South America toward Asia. As that warm water moves away, cold water rises up from the deep ocean to take its place. We call this process upwelling. But the Earth always likes to surprise us, right? So, from time to time, a cycle known as ENSO shows up and breaks those rules. This natural cycle is divided into 3 phases: La Niña, El Niño, and an in-between stage where things are relatively quiet, known as ENSO neutral. La Niña is the cold phase. When it happens, those tropical winds get even stronger than usual, shoving more warm water toward Asia. Near the Americas, super cold water from the deep ocean rushes up to the surface. This shifts the jet stream, those high-altitude winds that steer our weather further north. For the US, a La Niña year usually means a warmer, drier south and a much colder, rainier north. It also tends to make hurricane seasons in the Atlantic way more active and dangerous. El Niño is the exact opposite. It is the hot phase. This is when the tropical winds weaken or even reverse. The sea surface temperatures can reach 9 degrees Fahrenheit above their normal levels. Instead of being pushed away, all that warm water flows back east toward the Americas. This pulls the jet stream way south of where it usually is, and that changes the weather completely. Areas in the northern US and Canada stay warmer and drier than usual, while the southeast and the Gulf Coast get soaked with constant rain and flooding. El Niño and La Niña episodes tend to happen every 3 to 7 years, with each phase usually sticking around for about a year. But don't expect a fixed schedule. It happens. At the beginning of 2026, the world is watching it all unfold again. A weak La Niña is finally fading away, and little by little, it's turning into an El Niño. And experts think it could be a massive one. All the signs from the ocean and the atmosphere show a powerful El Niño pattern picking up speed as we head toward the fall. If the water keeps warming up at this rate, some meteorologists believe this event could become exceptionally strong. A super El Niño is on a whole different level. It happens when the Pacific gets so warm that it basically throws the world's weather off balance. This can lead to much more extreme weather shifts. Instead of just a little more rain, you get massive floods. Instead of a short period of dry weather, you get a serious drought. This event also pushes storms into places they don't normally go, and that ends up affecting the whole world. If you're not a big fan of summer, I have bad news. A new Godzilla El Niño is probably going to push global temperatures to record-breaking heights. It's going to be unbearably hot. The last time the world had to deal with a super El Niño was back in 2015. That year, the water in the Pacific got incredibly hot, and that set off a chain reaction of disasters around the globe. The hurricane season was unlike anything we'd ever seen. Usually we see 4 or 5 tropical cyclones in the Pacific. But in 2015, there were 16. That's insane. At one point, 3 massive Category 4 hurricanes named Kilo, Ignacio, and Jimena were all spinning at the exact same time out at sea. That was a first since we started keeping track. Luckily, none of them actually hit land. But we weren't always that lucky. In July 2015, Hurricane Dolores sent record-breaking rain into Southern California, causing over $50 million in damage. Later that same year, Hurricane Marty hit the coast of Mexico, leading to another $30 million in losses. South America was hit with way more rain than usual. Rivers in Argentina and Paraguay overflowed, forcing thousands of people to evacuate. Because of El Niño, 2015 became the hottest year on record at that time, and it brought terrible droughts. In Ethiopia, for example, some parts of the country got less than a third of their usual rain. Crops failed big time, and over 8 million people were left without enough food. So, are we going to face something that intense again? Well, it's hard to say. Most experts agree that an El Niño is in fact coming, but we're still not sure about its strength. Early data shows everything from a weak event to a record-breaking Super El Niño. Scientists are watching it closely, but they need a few more months to see how it actually behaves. The El Niño is expected to show up by summer. Usually we don't feel the effects right away, but since this one is moving so fast, we might start seeing weird weather sooner than usual. One big change we can expect has to do with the Atlantic hurricane season, and that's good news for the US. Usually, the El Niño lowers the overall numbers of hurricanes in the Atlantic. That's because it creates high air pressure and stronger winds high up in the sky that basically rip the storms apart before they can grow. In this part of the US, this makes the whole atmosphere more stable, which stops small storms from powering up into giant hurricanes. But the main impact of El Niño usually happens in winter, and it messes with the snow. If you live in the northern US or the Midwest, you will probably see a lot less snow than usual. Of course, these are all just predictions based on what happened in previous years, but it's not a perfect science. After all, we never see the exact same weather 2 years in a row, and when you throw an El Niño into the mix, things get even more unpredictable. One thing's for sure. Since this phenomenon affects millions of people, experts have to keep a close eye on it every year. Seasonal forecasts for El Niño and La Niña too show how the weather is likely to change, helping authorities plan ahead for energy and water needs. This way, cities can prepare for too much rain or severe drought, and farmers know what to expect for their crops. But most importantly, weather alerts let people find shelters and get communities ready before disasters hit, and that saves lives.
We are up for a crazy Atlantic hurricane season. It may be even worse than that of 2005, the year that brought us Hurricane Katrina. That one took 1,392 lives and cost the country over $100 billion. Experts predict there will be between 17 to 25 total named storms. Some of these storms are about to become hurricanes, with winds reaching over 100 miles per hour or higher. We're already seeing storms sweep across the country, bringing dangers like tornadoes, flooding, and hail. You gotta thank the El Niño Southern Oscillation, or ENSO, for this. This complicated term has to do with El Niño and La Niña, the two giant forces that basically shape our world. Normally, winds in the Pacific Ocean blow west along the equator, moving warm water from South America towards Asia. This warm water is replaced by cold water rising from the depths of the Pacific. But during El Niño and La Niña, this usual pattern is messed up. El Niño is the warm phase of the ENSO cycle. During El Niño, the equatorial winds weaken, causing warm water to shift back towards the west coast of the Americas. This means less cold water rises to the surface. The weather in northern parts of the US and Canada become drier and warmer because of it. But there are wetter conditions in southern states. In the Atlantic, El Niño weakens hurricane seasons, and it ramps up hurricane activity in the central and eastern Pacific. In Africa, it brings more rain to East Africa but less to Southern Africa, West Africa, and parts of the Sahara. La Niña is the cold phase of the Enso cycle. During this phase, the westward winds along the equator in the Pacific are stronger than usual, and they push more warm water towards Asia. And because of it, colder, nutrient-rich water rises to the surface along the Americas' west coast. These colder Pacific waters push the jet stream northward, giving us drier weather in the southern U.S., but wetter and colder conditions in the Pacific Northwest and Canada. La Niña also brings warmer winters to the southern U.S. and cooler than normal temperatures to the north. La Niña usually calms hurricane activity in the Pacific, but intensifies it in the Atlantic. In 2023, El Niño was in charge, and it took most storms up before they got to the U.S. But this year, we've switched to La Niña, and this lady brings us colder water in the Pacific and a pattern that lets storms move a little farther west and reach the Caribbean. And when they get there, they can easily move into the Gulf and affect Florida and other states. The upcoming intense Atlantic hurricane season also has to do with a strong monsoon season in West Africa. It creates moisture and waves off Africa's coast and can travel along the Atlantic and spur hurricanes. The Atlantic hurricane season runs from the 1st of June to the 30th of November, and most activity happens between mid-August and mid-October. Since the 1950s, tropical cyclones have been given names to make it easier for meteorologists to inform the public about them. You're more likely to remember that Leslie is coming than Hurricane X34D is on the way, right? So there are 20 names on the alphabetical list this year, from Alberto to Beryl to Valerie and William. Let's hope it won't get as terrible as the Galveston hurricane. The most fatal natural disaster in U.S. history hit Texas in the year 1900. A Category 4 hurricane smashed into Galveston, demolishing over 3,600 buildings with winds over 135 miles per hour. It took the lives of between 6,000 and 12,000 people. One of the reasons it became so fatal was poor communication policy. Days before the disaster, it was clear to a professional weather forecaster that the storm was moving west. But the Weather Bureau in Washington predicted it would go over Florida and up to New England, which was way off. The Bureau was just 10 years old then, so hurricane science in the U.S. wasn't very advanced. Cuban scientists were excellent at tracking storms because their region is so prone to them. So they knew it was heading towards the Gulf of Mexico. Unfortunately, the director of the Weather Bureau was so jealous that the Cuban forecasters were better than the American ones that he cut off the flow of information from Cuba and made it difficult for local forecasters to issue warnings without going through Washington. In the days before the storm hit, the chief observer in Galveston began to suspect that Washington's forecast was wrong and tried to warn the city, but it was too late. The hurricane left Galveston in ruins. After this hurricane, the Weather Bureau started improving communication, both internationally and within the U.S. The officials in charge are doing everything possible to improve forecasts, support the people, and help the affected areas recover more easily after the hurricanes hit. They're going to try new forecast models to predict tropical cyclones getting stronger, help emergency and water managers prepare for potential flooding, and protect people and infrastructure. Coastal weather buoys in the tropical western Atlantic and Caribbean have been upgraded, and new drifters and sail drones, underwater gliders, and a lightweight drop sonde will provide real-time data. There are also some things you can do to ensure your safety before, during, and after a hurricane. If you live in a hurricane-prone area, Florida, Georgia, and the Carolinas, you must always be prepared before the high storm season. Make up a family disaster plan that will outline your actions during an emergency. Map out several evacuation routes in case your primary one is blocked, and decide on a meeting place if you get separated. You can arrange drills to teach family members how to shut off water, gas, and electricity, and even make sure the youngest knows how to call emergency services. Pack a disaster kit that will be ready to go at a moment's notice. It should include essentials like food, water, a first aid kit, and flashlights to last at least 72 hours on your own. You can buy a generator to make sure you have electricity in case of a power outage until the power returns. Keep it in a secure place, away from rain and rising water, with proper ventilation. You're also going to need self-powered radios and flashlights. If you can, add a safe room to your house that's strengthened to withstand high winds with reinforced concrete ceiling, floor, and walls. Make sure you have enough canned and non-perishable food and bottled water for at least 3 days. When the storm is about to hit, head north to get away from it, where it will be much weaker by the time it gets there. It's much safer to keep your family and pets together away from the storm than trying to ride it out at home. Try to go in one car if possible. Always follow local evacuation orders, especially if you're in a mobile home. Fill up your gas tank and give yourself plenty of time to get out. Never leave your pets behind. Debris, floodwaters, or flying objects can be dangerous for them. If you're staying put during a storm, you need a safe spot for you, your family, and your pets. This place shouldn't have any windows or skylights. If you're hiding at home, close all interior doors and secure the exterior ones. Quickly find an interior room with strong walls and no windows, like a bathroom or closet. If your home isn't safe, look for a community shelter. Get to your shelter at least 2 hours before the storm hits so it doesn't catch you outside. Bring a battery-powered radio with extra batteries for updates every 15 to 30 minutes. Never leave your shelter even if it seems calm, as conditions can get worse quickly, especially if you're in the eye of the storm. For extra protection, lie on the floor under something sturdy like a table. Don't use electric appliances, phones, or showers during the storm. Don't leave your shelter until you get the official all clear from the authorities. Be careful. There will be many hazards outside.
Welcome to the Spirit of Discovery cruise ship, which will take you on an unforgettable sea voyage around the Canary Islands. The azure endless ocean, delicious food, the highest service, premium cabins, and a terrible nightmare that you will probably remember for the rest of your life. This is exactly how one luxury trip of the Saga Cruises Company ended last year. Instead of relaxing during the cruise, passengers felt fear and horror, and even had health problems. And that's why. On October 24th, the Spirit of Discovery liner started a 2-week cruise around the Canary Islands. There were about 1,500 people on board. About 1,000 were passengers, and the rest were crew members. The first week went great, but then the liner encountered a serious problem called nature. There were strong winds and big waves. The captain decided to return to the UK ahead of time, but the decision was made too late. The ship was caught in a severe storm in the Bay of Biscay. A powerful wind with a force of 11 points hit the vessel. To make it easier for you to understand, the 11-point wind is able to tear out trees together with roots, destroy residential buildings, and plunge entire cities into chaos. Such a storm is rare, but Spirit of Discovery was unlucky enough to get into its epicenter. 11 points is the penultimate place on the Beaufort scale, which determines the wind rating. The most powerful storm has 12 points, and this is a hurricane. The wind reached a speed of 65 miles per hour, which is about the same as the average speed of a car on a highway. Not only did it push the Spirit of Discovery, but it also raised huge waves 25 feet high. Just imagine a wall of water the height of a 3-story building collapsing on a lone ocean liner. At that moment, the captain sent a message to all the passengers through the cabin speakers so that no one left their place. And his voice sounded worried enough. All the passengers had to lie down and hold on tight. According to the witnesses' words, the ship remained caught in the storm for about 15 hours. They held on with all their might so as not to crash into the walls and floor. All this time, tables were flying around the ship, dishes were breaking, furniture was moving all over the cabins. The waves smashed windows, partitions, and doors. Some people were knocked down because they couldn't hold on for so long. The storm hurled the passengers from ceiling to floor, from wall to wall. The ship's crew turned the dining room into a medical area to provide assistance to those who had been hurt. Despite the difficult and terrible conditions, the ship's team did a great job. They regularly informed passengers about the current situation and tried to calm everyone down. There was no panic and chaos on board. When the storm finally ended, the ship continued its journey and finally reached land, where medics urgently evacuated 8 passengers to the hospital. One of them was never able to survive this storm. It's good the ship didn't meet a rogue wave during the storm. This is a natural phenomenon that can appear during a storm and even in still water. It's a giant wave with a height of 60 feet. Like a 6-story house, it collapses onto a ship with incredible speed and capsizes it. And then the wave suddenly disappears. This is no joke. A similar wave has been recorded in the Gulf Stream off of Charleston, South Carolina. It's scary to get in its way. Now, let's go back to the past to remember one of the most terrible maritime tragedies. No, we're not talking about the Titanic. We'll talk about the Greek liner Laconia, which set sail from the English port of Southampton on December 19, 1963, with more than 600 people on board. However, just 3 days later, a terrible tragedy happened to the ship in the boundless waters of the Atlantic. At 11 p.m., in the barbershop hall, an electrical malfunction occurred. The problem led to a fire, which quickly spread to other rooms. The crew couldn't cope with it, since the fire was spreading too fast. The ship's team turned on the fire alarm, but there was no command to leave the vessel. Only 2 hours later, the captain ordered the passengers to evacuate. All this time, people were either relaxing in their cabins or enjoying a party in the ballroom. The crew was probably trying to put out the fire without causing panic. However, when the situation became critical, the evacuation began. People panicked and ran to the lifeboats, but many didn't manage to get inside. One of them was John Morris. He survived this catastrophe and shared his memories of how he put his family in a lifeboat while he stayed on board the ship. He didn't even have a life jacket. Since there was nowhere to go, the ship's crew opened a bar so that people could relax a little. However, at that moment, boilers began to explode inside the ship, and it became clear the vessel wouldn't stay afloat for too long. John Morris decided to jump into the water right in his tuxedo. As soon as he was overboard, he grabbed onto a piece of wooden deck cargo and swam as far away from the ship as he could. The giant liner could sink at any moment, and when such a huge object goes down to the seabed, it forms a water funnel that pulls along everything around. Rescuers arrived at the scene sometime later. Fortunately, John Morris's pregnant wife and young son were alive, but his mother-in-law unfortunately didn't survive the disaster, like many other people that day. Of course, after this incident, the Greek Ministry of Merchant Marine initiated a thorough investigation. For 2 years, they collected information from passengers and the captain, studied the technical characteristics of the ship, and eventually came to certain conclusions. According to them, the ship's crew gave the evacuation order too late. Not all passengers were able to get into lifeboats, but half of those boats remained on board because of the chaos that prevailed during the evacuation. Several officers of the liner were accused of negligence, but the captain and his first mate received the most criticism. As for John Morris, he stated that he felt himself under protection that day. Another unusual story happened on a cruise ship relatively recently. Spoiler alert, the ship didn't sink, there was no evacuation, and the weather was good. However, for many passengers, this journey became a real challenge. Imagine that you've been working for a long time and saving up money to go on your dream trip on the Celebrity Mercury cruise ship in the Caribbean. You arrive in South Carolina, from where the ship begins its journey. You get on board, looking forward to a week's rest. At first, everything is fine. People are having fun, chefs are cooking delicious dishes, and beautiful daytime landscapes turn into night parties. But then suddenly, many passengers start throwing up. Someone is in a hurry to go to the toilet, and someone stays and vomits right in the halls. The cruise turns into chaos. More and more people feel terrible because of unknown poisoning. You also visited the restaurant and eaten seafood, but fortunately, the disease has avoided you, which can't be said for more than 400 other passengers. Almost every 1 in 4 people on board face gastrointestinal problems. There were almost 2,000 people, and a quarter of them are in bad condition. Crew members do endless cleaning. They wash the deck, give people nausea pills, and ask them not to leave the cabin till the illness passes. The captain sends several samples ashore to determine what caused the poisoning. Unfortunately, the cruise is already ruined, and all the passengers have unpleasant memories. So the company organizing the trip issues certificates that can be used on future cruises. It's not the most pleasant experience, but it's still better than nothing. Now, imagine if, instead of just feeling sick, people got infected with some kind of bacterium that would turn them into zombies. It would be much more exciting and scary. Now, do you think you could survive on such a ship full of zombies? And how would you do that? Tell me about it in the comments.
In May 2024, stunning auroras adorning the night sky demonstrated all the power that solar storms emit as radiation. But sometimes, our sun does things that are far more destructive. I'm talking about solar particle events. During these events, blasts of protons coming directly from the surface of the sun can shoot out like giant cosmic searchlights. According to records, an extreme particle event hits Earth every 1,000 years or so. It often causes bad damage to the ozone layer and increases levels of ultraviolet radiation closer to the surface of our planet. Luckily, Earth's magnetic field acts as a powerful protective cocoon for our planet, fending off electrically charged radiation from the sun. In its normal state, this field functions like a ginormous bar magnet, with field lines rising from one pole, looping around the planet, and dropping at the other pole. This pattern is sometimes called an inverted grapefruit. This vertical orientation of the magnetic field at the poles allows some ionizing cosmic radiation to get through the field as far down as the upper atmosphere. There, it interacts with gas molecules and produces the glow we know as auroras. But over time, Earth's protective bubble changes. In the past century, the North Magnetic Pole moved across northern Canada at a speed of about 25 miles per year. Plus, it weakened by more than 6%. Even more shockingly, according to geological records, there have been periods of time as long as centuries and millennia when our planet's magnetic field was super weak or entirely absent. But we'll talk about those tragic times later. It's easy to imagine what our planet would look like without its protective bubble if you look at Mars. The red planet lost its global magnetic field long ago. And once this field disappeared, most of Mars's atmosphere vanished too. In May 2024, a strong solar particle event hit the planet. It disrupted the operation of the Mars Odyssey spacecraft and made radiation levels at the surface of the red planet rise around 30 times higher than what a person receives during a chest X-ray. The sun's outer atmosphere constantly emits a changing stream of electrons and protons, the solar wind. At the same time, the surface of the star also produces bursts of energy, mostly protons, during solar particle events. These bursts of energy have a connection to solar flares, extremely powerful bursts of electromagnetic radiation that can last from minutes to hours. Protons are way heavier than electrons and carry more energy. That's why they can reach lower levels of Earth's atmosphere, exciting gas molecules in the air. These excited molecules emit X-rays invisible to the unaided eye. Dozens and hundreds of relatively weak solar particle events happen during every solar cycle. Now, let's speak about solar cycles for a minute. You see, from a distance, the sun seems to be calm and steady, but if you zoom in, you'll see that its surface is constantly seething and churning. It keeps transforming from a uniform ocean of fire to a chaos of warped plasma and back again in a repeating cycle. Every 11 years or so, the magnetic field of our star gets tangled up. Imagine a ball of tightly wound rubber bands. That's what it looks like at such moments. And then, at one point, it snaps and flips completely, turning the North Pole into the South Pole, and vice versa. Right before this event, the sun steps up its activity. It starts to spit out giant blobs of fiery plasma, emit powerful streams of radiation, and grow planet-sized spots. This period has the name of solar maximum. It's a rather dangerous time for Earth, since it gets regularly hit by solar storms. Such storms have the potential to disrupt communications and damage power infrastructure. Even worse, solar storms can harm astronauts working in space and even make satellites crash into the planet. As the cycle ends, it fades back to the solar minimum, and then a new cycle begins. Anyway, back to our solar particle events. Researchers have found traces of extremely strong solar events happening throughout the history of Earth. And some of them were thousands of times stronger than anything our modern instruments have ever recorded. Such extreme solar particle events happen approximately every few millennia. The most recent one occurred around 993 CE. Beyond the immediate effect they have, solar particle events can kickstart a chain of chemical reactions in the upper atmosphere. And these processes often lead to depletion of ozone, which isn't a good thing. Ozone absorbs harmful solar UV radiation, which can damage not only our eyesight, but also the DNA of living beings. Plus, changing the amounts of ozone in the atmosphere can impact the climate. In a recent study, researchers used large computer models to examine how extreme solar particle events affect Earth. They found out that if a solar proton event arrives during a period of time when our planet's magnetic field is very weak, then ozone damage can last for 6 years, and the level of UV radiation might increase by 25%, boosting solar-induced DNA damage by around 50%. And apparently, this dramatic combination of a weak magnetic field and extreme solar proton events happens quite often. And some researchers believe that it may even explain a few mysterious occurrences in the past of our planet. For example, the most recent period of weak magnetic field started 42,000 years ago and lasted for around 1,000 years. This period included a temporary switch in the North and South Poles. Several major evolutionary events happened during that time. For example, the last Neanderthals disappeared in Europe, along with the extinction of marsupial megafauna in Australia. Yeah, sadly, we won't see any giant wombats and giant kangaroos anymore. One more, even bigger evolutionary event might also be linked to Earth's geomagnetic field. Multicellular animals appeared at the end of the Ediacaran period, which started around 635 million years ago, and it occurred after a 26 million year period of extremely weak or even absent magnetic field. The rapid evolution of different groups of animals in the Cambrian explosion, about 539 million years ago, might have also been related to high UV levels and geomagnetism. The simultaneous evolution of hard body shells and eyes in multiple unrelated groups could have been necessary to detect and avoid harmful incoming UV rays. A complete reversal of Earth's geomagnetic poles might have a serious impact on the climate of our planet. Luckily, such flips don't happen overnight. The entire process stretches over thousands of years. Plus, even though the magnetic pole weakens during a pole reversal, it doesn't disappear completely. That's why the magnetosphere continues protecting the planet from cosmic rays and charged solar particles, even though there might be some amount of particulate radiation that will make it to Earth's surface. Our planet's magnetic fields are generated by moving electric charges. If some material allows these charges to easily move in it, it's called a conductor. Metal is a great conductor, and we often use it to transfer electric currents from one place to another. In this case, the electric current's negative charge, called electrons, move through the metal. The current is what generates a magnetic field. Earth's outer core is made of liquid iron and nickel. In other words, there are layers and layers of conducting material inside our planet. Currents of charges are constantly moving throughout the core, and the liquid metal is also moving and circulating there, generating the magnetic field. This magnetic field, in turn, produces something resembling a bubble around the planet. It's called the magnetosphere, and it's located above the uppermost part of the atmosphere. This layer shields and deflects high-energy cosmic ray radiation, which otherwise would be extremely hazardous to people and other forms of life on Earth. The magnetosphere also interacts with the ionosphere, the layer of our planet's atmosphere containing loads of ions and free electrons and capable of reflecting radio waves. The interaction between these two layers and magnetized solar winds is what scientists call space weather. The solar wind is normally mild, and there's no space weather whatsoever. If you think you're safe from violent tornadoes because you aren't living in the tornado alley, you could be dangerously wrong. It's shifting to the east. It looks like we're about to see fewer single tornado days and more days with multiple powerful tornadoes. And because they're shifting into more populated areas, they could take more lives and ruin more homes. There isn't enough time to build infrastructure to protect everyone from this fast-moving danger. So the least you can do to save yourself is learn as much as you can about it. About 1,200 tornadoes hit the US every year. You gotta thank the unique geography that sets up the perfect conditions for it, especially in spring and summer. Winds from the Pacific drop moisture over the Rockies and become dry and cool as they move east. They collide with warm, humid air streams from the Gulf of Mexico over the flat terrain. And that's how unstable air and wind shear, which are the perfect conditions for tornadoes, are born. Historically, tornadoes were most common in Tornado Alley. This term was first used in the 1950s by two meteorologists as the title for their research project to study extreme weather in Texas and Oklahoma. Northeastern Texas and south-central Oklahoma are precisely the areas we think of when we talk about Tornado Alley. But in the past 10 years or so, it has shifted eastward by up to 500 miles. Now, eastern Missouri, Arkansas, western Tennessee, Kentucky, northern Mississippi, and Alabama see more tornadoes. The storms of early 2023 are great proof that this trend is real. A violent tornado hit Rolling Fork, Mississippi, and another outbreak caused huge damage in the new Tornado Alley. Data from the past 2 years shows that large tornado outbreaks with multiple twisters from a single weather system are also moving eastward and becoming more frequent and intense. The Tornado Alley is shifting eastward mainly because of supercells. Those strong thunderstorms with rotating updrafts create new tornadoes. Supercells form when warm, humid air near the ground interacts with cool, dry air higher up. You can say that we're living in the middle of a natural experiment. We see changes in the basic ingredients for severe storms. But we don't know how significant these changes are. Experts predict that supercell storms will become more frequent in the late winter and early spring and less common in the late summer and fall. The air in recent years is getting warmer and moister, and the interactions between air masses more and more common. Experts explain that the atmosphere is becoming more unstable, and the Gulf of Mexico sends more water vapor into the southeastern U.S. All these factors fuel the storms. Research also shows that the so-called dry line, which divides the wetter eastern U.S. from the drier western U.S., is shifting eastward too. This line has traditionally fallen along the 100th meridian, but has moved about 140 miles east since the late 1800s. This shift can affect where storms form, as the dry line works as a boundary for convection, where warm air rises and cold air sinks, fueling storms. Milder winters we've seen recently also mean more opportunities for unstable air masses to interact and form supercells earlier in the year. It's tricky to predict how the situation will change and how dangerous it is, because we don't have that much data on how weather patterns affect such short-lived events as tornadoes. The U.S. National Weather Service only began keeping tornado records in 1950, and they didn't catch many tornadoes in remote areas. Data shows that the number of days with tornadoes each year has decreased, but there's more tornado activity on those days when they do occur. The records also show that some years, tornadoes take the lives of up to 20 people across the US, and in other years, they take over 100 lives. But now, there are more people living in the paths of tornadoes because the US population has more than doubled since 1950. And the Southeast, where tornado activity could go up, has way more residents now. Texas and Oklahoma are well prepared with tornado shelters. But areas in the Southeast are less equipped. Plus, there are many mobile homes in the Southeast which are vulnerable to windstorms. Tornadoes in this region often strike at night, and they are 2.5 times more likely to cause fatalities. We could possibly have more events like the 2008 Super Tuesday tornado outbreak. It hit the southern US and lower Ohio Valley, and over just 15 hours, 87 tornadoes rushed through the area and caused massive trouble. 57 people lost their lives across 4 states and 18 counties, and many others were injured. The tornadoes were fueled by strong low-pressure systems that brought record warmth. There were supercells and rotating winds that produced these violent tornadoes. Early on February 5th, a squall line developed from eastern Texas to Missouri and moved east. One of the most intense tornadoes traveled 122 miles over 2 hours. By the early morning of February 6th, the severe weather threat shifted to the eastern U.S. It caused wind damage as the cold moved out to the Atlantic, with snow and freezing rain from Iowa to Quebec. It ruined many homes and even swept some of them from their foundation, made mobile homes fly, blew many vehicles and tractor trailers off Interstate 40, and threw some cars on trees. There were wind gusts over 50 miles an hour from Arkansas to Indiana, hail the size of softballs, toppled trees, and power outages everywhere. Some areas were flooded because of heavy rains and melting snow. All this led to over 1,000 flight cancellations at Chicago's O'Hare and disruptions at Toronto's airport. The data from scientists can help new areas of the U.S. prepare for more tornadoes coming their way. The people in authority will also need to improve community shelters and warning systems and educate the locals on tornado safety. You can also get prepared by learning 3 basic rules: get in, get down, and cover up. When you hear the warning for an upcoming tornado, get into the most interior room in your house and stay away from doors and windows. If you have a basement or an underground tornado shelter, hide there. If not, just be on the lowest floor possible. You can use whatever's at hand to protect yourself from debris. Clothing, pillows, blankets, a mattress, or a bulky table. Anything will do. There's a tip that says that the bathroom is the safest place to hide. It makes sense because those are mostly right in the center of homes. In March 2023, a man and his girlfriend in Rolling Fork, Mississippi survived a tornado in their bathtub. It got thrown into the air but landed safely amid the wreckage of their mobile home. But there's actually nothing extra safe about being in a bathtub with a mattress. Closets and walk-in showers that are deep inside the building can also offer good protection. Don't use elevators. You can get trapped inside if there's a power outage. Stay in your shelter until you're sure the tornado threat is over. If you can, listen for updates from the National Weather Service, local radio, or TV. Multiple tornadoes can hit the same area, so it might not be safe to leave even after one has passed. When you do leave your shelter, be very careful. There could be flooding, debris, collapsing buildings, and blocked roads. Stay away from fallen power lines and puddles with wires in them, and don't use matches or lighters in case of gas leaks. Stay away from damaged buildings as they could collapse at any time. Being in a car during a tornado isn't much safer than being out in the open or in a parking lot. Many people get injured trying to drive away from storms. Tornadoes can produce hailstones the size of softballs and can easily smash a windshield. If you find yourself outside when a tornado hits, try to get inside any building you can find. If that's not possible, get as low as you can. Even a ditch or culvert can be safer than your vehicle.
The ear-piercing sound of sirens brings your relaxing Saturday afternoon to a screeching halt. You jump out of the chair and run to the window. The sky is covered in black clouds all the way down to the horizon. The trees are nearly bent over flat from the gale-force winds. Together with the rain, golf ball-sized hail crashes into the ground, on rooftops, on parked cars. It sounds like a stampede right over your head. Car alarms are going off everywhere. Just then, crack! Huge bolts of lightning flash across the black sky. Then the monstrous grumble of thunder. Your heart jumps in your throat. As you peer through the window at the sudden chaos outside, you're filled with a primal fear of the power of nature. You snap back to reality. The sirens! Gotta get to the basement! You start to turn away from the window, and that's when you see it. A massive tornado ripping along the city street. It's throwing entire motorcycles, refrigerators, and even trees like baseballs. The roof of that building starts peeling off like a Band-Aid. The twister even lifts cars and pieces of asphalt as if they're made of feathers. It seems this tornado will flatten your city within an hour tops. You finally snap out of your hypnosis and run to the basement. The sound of the city being ripped apart terrifies you as you hunker down below as low as you can. But after about 20 minutes, everything is suddenly silent. You head out to see the clouds have disappeared, and the sun's rays illuminate the street. Luckily, your house was spared, but your modern city now looks more like ancient ruins. Stop. Tornadoes never come into cities, right? Yeah, they do. This monster doesn't care where it goes and what it eats along the way. While we're at it, you can forget about the myth that tornadoes will magically stop when they meet rivers, lakes, or mountains. They just keep on going. But about that no twisters in the city thing, about 1,000 tornadoes hit the US each year. That's 75% of all the tornadoes in the world. Most of these monsters occur in a strip, okay, more like a long blob, running up and down through the middle of the country. It's an area aptly dubbed Tornado Alley, a perfect spot for these things to form. You get cold, dry air coming down from Canada, meeting warm, humid air traveling north from the Gulf of Mexico. Warm air is less dense than cold air, so it rises and creates a strong updraft. Water droplets surround it to create the funnel cloud. There you go, recipe for a tornado. Now, if you closed your eyes, spun around, and put your finger on a map of the US, the chances of your finger landing on a major city are pretty slim. If you gathered all the cities in the whole country into one area, it would only be 3% of the US's entire land. Just like your finger, the likelihood of a tornado striking in the city is much smaller than landing in a rural area. When it comes down to it, tornadoes can touch down in big cities. They just hardly ever do, thanks to sheer chance. Another surprising myth. You always see a tornado coming because, funnel cloud right ahead. Not true. The approaching funnel can be completely camouflaged in a wall of rain. You might finally see it when it's right on top of you. In this case, you'd better trust your hearing. First, tornado warning sirens go off if you're in a place that has them. Second, listen for a loud rumble that sounds like a train coming. That's a sure sign this beast is somewhere nearby. Many people immediately start heading for shelter when they see green clouds in the sky, because we all believe it's the #1 sign of a tornado coming. Don't buy it. Yes, a green sky is a sign of a severe thunderstorm that's powerful enough to produce tornadoes, but it's not a guarantee like many people see it. While we're at it, you know how movies show the ground ripping apart during earthquakes? The gaping hole that swallows cars, houses, entire cities? Not a shred of truth to this. A crack may appear in the ground with major earthquakes, but it rarely exceeds a couple feet wide. One of the most overspread myths out there is that lightning will never strike the same place twice. Tell that to the Empire State Building. It gets hit by bolts of lightning at least 25 times a year. Pretty sure nobody's picking the building up and moving it to different locations. Yes, lightning likes really tall things, and it's not shy to keep coming back. As for that old warning about your cell phone or jewelry attracting lightning, busted. There hasn't been any scientific support for the idea that personal objects with metal in them attract lightning. You still shouldn't be out and about during a storm though, cell phone in hand or not. Now, if you're looking for a tsunami and only focused on giant walls of water, you might never see one, even if it's right in front of you. Tsunamis aren't always massive tidal waves crashing into the shore. More often than not, they look like the tide is rising extremely rapidly, receding and rising again until it overspills into the city. Not that tsunamis never form walls of water, it's just not as common. Picture Earth. Are you imagining a perfect ball? Well, to resemble the truth more, squash the poles down a little. There, now you have a realistic Earth. Scientists call the Earth an irregular sphere, or ellipsoid in fancy terms. The planet rotates on its axis, causing the equator to bulge out a bit, just like what happens when you spin fast on a merry-go-round. You feel pulled out and away from the center. What's the highest point on Earth? Everest, of course. But if we go from the point furthest away from the center of the Earth, the crown goes to Mount Chimborazo in the Andes. Its peak is actually 6,800 feet closer to space than the summit of Everest. That's because Chimborazo sits near the equator, where the planet's bulge is greatest. The blue whale weighs as much as 30 elephants, makes sounds louder than a jet, and eats 4 tons of food every day. It's the largest living creature this planet has ever seen. Only, not technically. Head to the Malheur National Forest in Oregon, home to a creature that weighs as much as 20 blue whales. The honey mushroom is a humongous fungus colony united into a common system. The giant covers an area of 1,500 football fields, and it's thousands of years old. Ask anyone to draw the sun, and they'll draw a happy yellow circle. But if you look at our star from the moon or the International Space Station, you'll see that it's actually white. From Earth, the sun looks yellow or red thanks to the atmosphere acting like a filter. Most people think time is constant and moves at the same speed no matter where you are. But the speed of time depends on how close the watch is to Earth. The weaker the gravity, the faster time passes. So the person living in the apartment above you is aging faster than you. Now, it's only 90 billionths of a second faster per 1 foot higher, so don't expect to notice a difference if you decide to move to the first floor. The ground under your feet feels pretty solid and whole, but in reality, the Earth's crust is all broken up into plates surfing on oceans of liquid rock called magma. You don't feel it, but the ground under you is moving a little over ½ an inch per year. That's about the same rate your toenails grow. Largest desert in the world? Easy. The Sahara. Nope. It's Antarctica, which is almost 2 times bigger than the Sahara. A desert isn't just a scorching sandy place where it doesn't rain. It's a place with very little precipitation, so that includes snow too. In some parts of Antarctica, it hasn't rained or snowed for millions of years. In other parts, snow does fall, though rarely. Point is, there's a myth that it doesn't snow in extreme cold. Antarctica is the coldest place on Earth, and it snows there. There is some truth to this old saying. Cold is drier. It doesn't retain moisture as well. You need moisture to produce raindrops and snowflakes. That's why there are fewer chances for snowfall when temperatures drop so low.
Gosh. Wow! Whoa! All right, buddy. No time to think. Whoa! Let's try to survive. Wow! I gotta move as fast as I can! It's already here! Ugh. Everything's falling apart! I hope this way works! Let's go! Wow! Let's go this way! Hey! I didn't break a single bone. Okay now, what's next? Oh no, not ready to give up yet! No worries. There's a main road behind these houses. Let's try to get there. Get into the car! Hurry up, babe!
We need to get out of here. Now!
Let's go! Whoa! Did you see that? Oh, watch out!
Ah! Look out! We need to get to a safe space.
Don't panic. We'll get out of here. Look! This is it! Hold on!
Ah! Whoa! Here we go!
You still have a chance to swim away.
Whoa! Can't believe we did it!
Congratulations, you're saved. Thankfully, it's just a simulation and no one got hurt.
Come on, let's get out of here. No! No! It can't be! It's a tsunami! Whoa! Hold on tight! We need to go faster! Whoa! It's catching us! We have to get to the land! Look out! It's too late! Brace yourself! This is going to be a bumpy ride! Keep going! We're back in the city? Oh no. Okay, we need to get off this boat. Whoa, that was crazy. Be careful, it's slippery. Go on that roof. Ah! Oh, you saved me. I thought I was a goner. We can move along that fence. Go! There's no time to waste! Oh no. We need to get onto that building. We're almost there. Get to the top of the tower. Look, there's a helicopter. That's our ticket out of here. We're safe at last. I can't believe it.
Whoa!
Whoa, that was close, huh? Gotta keep going! Wah!
What are we gonna do now? Oh no!
Made it! Phew! Wow!
He can't help us, Ava. We have to navigate this boat on our own.
Whoa, it's so shaky.
This weather is too stormy for a cruise.
Watch your head, babe!
Look,
No time to panic. Let's get out of here.
ouch.
Ava, are you okay?
No worries. I'm all right.
Grab something and hold on tight. You can be washed away by a wave.
Okay. Look out.
Wow. This city is a hot mess.
Careful. Maybe we could try to get on a roof.
Yeah. It's not safe to stay on board. Are you ready?
Yeah.
See this building? We need to get inside.
Ava, where are you? Can you hear me?
Hey, wait for me. Everything's falling apart. It feels a little dizzy. Okay, let's try this way.
Oh, there you are.
Phew, I'm so glad you're okay.
Nice view, huh?
Whoa! Have you ever seen anything like this? No! We need to get out of here. Now! Look out! Ah! Come on! We need to get to a safe space. What are we going to do? Ah! We need to go now! We need to hurry up. Please! We have to get out of here! We need to get out of here. Here we go. We made it.
The air is bone dry and the wind is out of control. You feel like you're standing in front of a fireplace, but you're not. You're standing in your backyard about to grill up a feast when you suddenly see the trees shaking uncontrollably. Leaves are falling like confetti. The wind just blew your last piece of laundry into the great unknown. You look around and everyone else is just as confused and scared as you are. In the distance, you see a red horizon of fire in the forest and a large vortex touching the sky. You drop everything and make a break for it. You'll be lucky to outrun a tornado. They usually move at around 30 miles per hour, but can reach up to 70. Imagine running away from a giant twister, hurtling towards you at Usain Bolt speed. The roads are crowded with people trying to find shelter or just get out of town. You get in your car and try to start it, but the wind knocks a sign over. It smashes your windshield. Anyway, a big tornado is powerful enough to swing your entire car around. You gotta go on foot. Best bet? Head for your buddy's house. They have a deep basement stocked with supplies. Whenever a tornado flies on by, try to take cover somewhere underground. If you don't have a basement, avoid any windows and try to stay underneath something sturdy to protect yourself. You're running to your friend's place. Everything around you is getting swept up by the insane winds. But when you turn around, you see the tornado turning reddish. You can barely see it because of the debris, but the spinning vortex, it's on fire. It's a fire tornado. These spinning flame winds can reach 140 miles per hour and can be between 15 to 150 feet tall and as much as 500 feet wide. These monsters occur when tons of smoke get whirled around, so the thunderstorm starts to act like a tornado. By the way, many fire tornadoes can even occur in a bonfire and are called fire whirls. Next time you're camping or setting up your living room fireplace, check it out. You might just spot one spinning around in there. Anyway, it's getting closer and closer, throwing ash all over. It's already pretty hard for you to see where you're going. You use your hands to wave off some of the smoke and ash flying around your face, but it's useless. You keep sprinting as fast as you can until you spot a huge truck. Just park right there in the middle of the road. You crawl underneath. It's one of those trucks that has like 20 wheels. They look so big and heavy up close. Then you hear a creaking sound and a humming sound. The wheels, they look magical. Gracefully, they start lifting off the ground, as if the truck's part of some Vegas magic act. As the tornado gets closer, the wheels rise higher. Better to be far away from here when the truck smashes back down to earth. You crawl out and keep running. You find a convenience store to take cover in, making sure not to stand too close to the glass. You head as far into the store as you can, ready to wait this thing out. But all around you, the land is burning. This fiery twister is a monster, and it's charging towards you. You look out in the distance and see another fire tornado wrecking another part of the city. In order for a tornado to form, it needs open space. That's why many of the tornadoes you see on the news happen in the same part of the U.S., where there aren't many mountains and it's nice and flat. But of course, they can happen anywhere. It's not normal to see tornadoes in the bustling downtowns of America's biggest cities. They need a lot of open space for the rotating vortex to happen. But today is not a normal day. A tornado forms in a supercell thunderstorm. That's when you have two different air temperatures going at it. The vortex you see in tornadoes forms when warm air and moisture come in from above. Below, it's a mess. The end result, the huge spiral funnel cloud we see in every tornado movie. Meteorologists can predict tornadoes somewhat by monitoring the amount of moisture in the air. Every second counts, so keep the TV on next time there's a storm brewing near you. But this doesn't really apply for a fire tornado. The winds are getting stronger and you're feeling the heat even inside the store. Outside, spiraling flamethrowers are torching everything in their path. It may be too late to find an underground shelter. You improvise a way to help protect yourself by hiding underneath the cash register. And now, you can't see anything. There's ash everywhere and the windows are all smashed, thanks tornado. Ash is one of the most dangerous parts of a fire tornado, unless you're not really into breathing or seeing. Your best bet would be to stay as low as you can to the ground. Since smoke rises, there might still be just enough oxygen down there. Crawling your way along will prevent you from getting struck by any flying objects or debris. The fires are now spreading, and there's a lot more smoke. The trees outside have caught fire, and there are glowing embers as far as the eye can see. These embers can travel more than a mile and can start fires on their own. Now that it's really going crazy, stuff in the store starts flying about, like the smoke wasn't bad enough. You feel like you're inside a snack-filled erupting volcano. It's only a matter of time before the table you're hiding under will get pulled up into the air. The sound inside the store is intense, like sitting next to a jet engine. You can't tell if you're sweating from the heat or from adrenaline. But suddenly, you see someone at the other end of the store waving at you, trying to tell you something. They have an underground storage room. You're saved. But getting there is going to be a real problem. You see, the table screw's getting loose, getting ready to fly into the air. You find a bottle of water next to you and rip a piece of cloth from your shirt. By using a wet cloth, you're able to filter out some of the nasty stuff in the air to help you keep breathing. So you crawl your way out from underneath the table and make your way to the underground storage room. But the ground is covered with broken glass, and there are cans and stuff everywhere. Even the cans are starting to heat up. You crawl like a sloth, trying to avoid anything pointy. The fire tornado is still out there, and it's getting even closer. You finally make it, and the clerk pulls you down the stairs. It's dark, but there's a single battery-powered lamp to help you see. When it comes to fire tornadoes, it's best to just wait it out. Most of these firestorms don't last that long. So you relax, or try to, and wash your face in a nearby sink. You wipe off all the black ash from your face and breathe normally again. But as you get a bit more relaxed, you feel the ground shaking. Everything around you starts to fall. You and the clerk duck behind a pile of canned goods. Then the tornado takes it up a notch. The store above you gets lifted up off the ground. The only things left, steel and concrete foundations and a couple of random columns. The steel door that's separating you from the outside is barely holding it together. You can see the screws getting loose. You can actually see fire enter the storage room. Everything in the room gets toppled over in an instant. The wind is even louder than before. But then, it's over. Those few minutes felt like hours. You and the clerk climb out and see, well, not much to be honest. The convenience store looks like it got ripped off like a Band-Aid. And all around you, a town you can't even recognize anymore. The big problem with these fire tornadoes is the fires they leave behind. They can ruin towns, forests, farms, and lives. It's 9:59 a.m. when a man is jolted awake in his bed by a powerful, mysterious force. While he's trying to figure out what's going on, a giant 100-foot-tall column of water is already surging toward his hometown. In 20 minutes, most of his friends and family members will lose their lives when a sky-high wall of water sweeps away buildings, trees, and cars. And it can happen to you at any given time. It's the day after Christmas in 2004. Thousands of tourists from Europe and America are enjoying tropical beaches in Thailand, Sri Lanka, and Indonesia when a powerful undersea earthquake strikes off the western coast of northern Sumatra, Indonesia. It's a 9.3 magnitude earthquake, the most powerful ever recorded in Asia. It triggers one of the largest tsunamis in history, the Boxing Day tsunami, which will take the lives of 230,000 people within a few hours. The city of Banda Aceh in Sumatra, Indonesia, home to 260,000 people, is the closest to the earthquake's epicenter. In less than half an hour after the quake, huge 10-story tall waves crash into the city. More than 60,000 people lose their lives immediately. The destruction is so severe that almost no one in its path survives. Next, the tsunami hits Thailand. The waves, rushing at a mind-boggling 500 miles per hour across the Indian Ocean, reach the shores of Phang Nang and Phuket about 90 minutes later. Despite such a significant time gap, Both locals and tourists are caught totally off guard. Many beachgoers even walk out onto the beach, curious about the strangely receding sea, only to be overtaken by a towering wall of water. Nearly 5,400 people, including 2,000 foreign tourists, won't survive that day in Thailand. An hour after Thailand, the tsunami hits southeastern India near Chennai. Debris-filled waves push miles inland, taking the lives of more than 10,000 people. Sri Lanka faces even worse devastation. The island will lose over 30,000 people, and hundreds of thousands will become homeless. The tsunami's incredible strength is evident even far away. 8 hours later, it claims its last victims in South Africa, 5,000 miles from the quake's epicenter. There, rogue waves catch swimmers off guard. Researchers from NOAA's Center for Tsunami Research explain that the destruction was due to the sheer power of the earthquake. It originated from a megathrust fault. That's where heavy ocean plates dive beneath lighter continental plates. These faults are the largest in the world and lie underwater. The 2004 earthquake ruptured a 900-mile stretch of the Indian and Australian plates, 31 miles beneath the seafloor. Plus, instead of one quick jolt, the quake lasted for 10 minutes and released an unimaginable amount of energy. During the shaking, massive sections of the seafloor moved upwards by 130 feet. That's a lot. Such a sudden movement set colossal waves rippling across the ocean. Imagine it like dropping a massive pebble into the water. The thing is, tsunami waves aren't like those surfing waves you may imagine. No, they look like a fast-moving whitewater river that floods everything in its way. If you get caught in those raging waters, it's almost impossible to survive. If the powerful currents don't pull you under, floating debris will. That's the reason why, during earthquakes, there are usually many injuries and fewer lives lost. With tsunamis, it's the opposite. There's way fewer injuries than fatalities because it's too hard to survive. Catastrophic tsunamis, like the one in 2004, are rare. That's why India and Sri Lanka had no record of such disasters. This lack of experience, combined with the absence of warning systems, made the consequences of the disaster even more tragic. People didn't feel the earthquake because they were far from the epicenter. And with no natural warning signs, no official alerts, and no history of tsunamis, the waves that hit crowded coastlines had devastating effects. By the way, the Pacific Ocean, the largest ocean on Earth, is where most earthquakes and tsunamis occur. Locally damaging tsunamis strike somewhere in this ocean about once every 1 to 2 years. 76% of the recorded fatal tsunamis happened in the Pacific. And 99% of tsunami casualties are caused by local or regional tsunamis, which occur more often and hit quickly. But then a question arises: could a tsunami as devastating as the Boxing Day one happen again? Unfortunately, the answer isn't very straightforward. A warning system has indeed been established in the Indian Ocean. Its goal is to alert coastal nations of potential tsunamis. But human behavior is still a critical challenge. This became clear during a real-life test in 2012. That's when many residents of Banda Aceh, Indonesia, simply ignored evacuation towers after a tsunami warning. People never seem to learn, huh? The Indian Ocean Warning Network uses undersea pressure sensors placed near tectonic plate fault lines. These sensors detect any changes and transmit data to surface buoys, which then send it via satellite to control centers on land. Authorities analyze the information and decide whether to issue warnings and evacuate at-risk areas. Aceh, located on one of the world's most active fault lines, implemented additional safeguards. They installed sirens in coastal cities, and people get alerts on their cell phones. Plus, there are evacuation towers, reinforced concrete structures capable of holding 500 people. They are special safe zones. Authorities did test how well prepared people were. In 2009, 18 Indian Ocean countries participated in an evacuation drill, simulating a large earthquake. Thousands of coastal communities took part in this drill, and officials concluded that the exercise had been a success. Fast forward to the system's first real test in April 2012. An 8.6 magnitude undersea earthquake west of Aceh triggered tsunami warnings. And even though there were no significant waves, the whole situation revealed critical flaws. Many residents ignored evacuation towers, choosing instead to flee by car or motorbike. This led to citywide traffic jams, with people getting stranded in areas vulnerable to a potential tsunami. It was chaos. Some residents even went back to the beach to look for the signs of a tsunami, which is a life-threatening mistake. So apparently, there is still a lot of work to do when it comes to tsunami survival. But what you need to know by heart is the signs of an impending tsunami. First of all, it's severe ground shaking. Strong earthquakes near coastal areas can generate tsunamis. If you notice that water on the beach starts to recede at an alarming rate, exposing the ocean floor, reefs, and stranded fish, run. Then there might be unusual ocean sounds. Keep in mind that a loud roaring noise, resembling a train or jet engine, may accompany an approaching tsunami. If you notice any of these warning signs, do not wait for official evacuation orders. Leave low-lying coastal areas immediately and move to higher ground as fast as possible. If you're at home, make sure your family members know about the tsunami and follow official guidance. You should remember that locally generated tsunamis may strike within minutes. You have to act quickly. If it's a distant tsunami, you may have more time to evacuate. If you don't have an opportunity to move inland, hide in high reinforced concrete buildings. Avoid staying in small buildings or homes in low-lying areas. If you're on a boat, stay offshore. Tsunami activity isn't as dangerous in deep water, so avoid returning to port during a tsunami warning. If you're already in port, check with harbor authorities for guidance. If it's possible to move to deep water, do it in an orderly manner. It may be safer for small boat owners to leave their vessel and move to higher ground. And always, prioritize moving to higher ground over saving your belongings. If you live in a coastal area, you can take some measures to protect your property in advance. Since most tsunami waves are under 10 feet, you may consider elevating your house. It can reduce damage. You can also consult an engineer to assess and reinforce your home. And finally, don't forget to protect outbuildings too, and create fences that will allow animals to reach higher ground.